Good afternoon, everyone. I am welcome you all of you to today online seminar organized by BioCareer Circle WhatsApp community. Our topic for today is how to build a strong research profile for MS, PhD, projects, papers, and internship. Thank you all for joining us. Before we begin the session, let us start with a short prayer song to create a positive and peaceful start of program.
ஆயிரம் கரங்கள் நீட்டி அழைக்கின்ற தாயே போற்றி. ஆயிரம் கரங்கள் நீட்டி அழைக்கின்ற தாயே போற்றி. அருள் பொங்கும் முகத்தை காட்டி இருள் நீக்கும் தந்தாய் போற்றி. பரிந்து சாலச் சகலரை அழைப்பாய் போற்றி. தழைக்கும் ஓர் உயிர்கட்கெல்லாம் துணைக்கரம் கொடுப்பாய் போற்றி. தூயவர் இதயம் போல துலங்கிடும் ஒளியே போற்றி. தூரத்தே நெருப்பை வைத்து சாரத்தை தருவாய் போற்றி. ஞாயிறே நலமே வாழ்க நாயகன் வடிவே போற்றி. நானிலம் உலகாள் மட்டும் போற்றுவோம் போற்றி போற்றி.
Are you a slow reader who wants to week? My name is Rajneesh and I am the world
Thank you for joining the prayer. A good beginning set the tone for the entire program, and with this positive start, we will now move forward with our session. Once again, good afternoon to everyone present here. On behalf of BioCareer Circle WhatsApp community, I extend a warm and respectful welcome to all participants joining us for today's online seminar titled How to Build a Strong Research Profile for MS, PhD, Projects, Papers, and Internships. We are honored to have with us Ms. Lakshmi Priya Ma'am, research scholar from the Department of Biotechnology, Vellore Institute of Technology. Ma'am expertise in tissue engineering, 3D bioprinting, molecular biology, and advanced analytical techniques make her a highly valuable resource for aspiring researchers. This seminar has been organized with the objective of guiding students and young professionals who aim to pursue higher studies and research careers in India and abroad. Building a strong research profile is essential in today's academic environment, and we believe today's session will provide clarity, direction, and practical insights. I thank all our community members for your continued support and active participation. Once again, I welcome each one of you and wish you an enriching and informative session. Thank you. Okay, now I kindly invite Ms. Lakshmi Priya ma'am to begin the seminar. Over to you, ma'am.
Thank you, Mr. Vishwanathan. Can you hear me?
Yes, ma'am.
Yeah, thank you. It is a pleasure to hear today, and thank you for giving me this opportunity to interact with such a wonderful topic, which means how to build a strong research profile for MS and PhD based on projects, papers, and internships. My name is Lakshmi Priya, Department of Biotechnology, and I'm working as a research scholar in the Vellore Institute of Technology. Before we go too deeper into advanced topics, let me begin with very simple but important question. What is biomedical engineering? We all know that what is biomedical engineering is where biology, medicine and engineering come together to solve real healthcare problems. In simple words, it is application of engineering principles to understand biological systems and to develop technologicals that improve human health. Think about devices like MRI scanners, artificial organs, prosthetic limbs, stents, biosensor, or even tissue engineering like skins, etc. All these are outcomes of biomedical engineering. This field does not belong only to doctors or only to engineers. This is belong to who can connect both biology and engineering. As a biomedical engineer, we don't just ask us what is the disease. We just ask how can we design a solution for that disease to cure or to give a solution. How can we make a diagnosis faster? And we can have to ask how can we make treatment safer and how can we help the body to heal better. In India, the field of biomedical engineering is growing rapidly. According to All India Survey of Higher Education, 15,000 biomedical engineers graduate every year at the undergraduate level. This clearly shows that increasing importance of biomedical engineer in our healthcare and research ecosystem. However, producing graduates is only the first step, and the real challenge and the opportunity is how we transform this knowledge into innovation, research, and impactful healthcare solutions. It is the major drawback of this. So, biomedical engineering is not just a degree, it is a problem solving mindset where engineering tools are used with a deep understanding of biology to improve quality of life. Uh, we all have that one question, what next after undergraduation? Some of you may be thinking of about job, some about higher studies, some about research, and many of you might be thinking of I'm interested in everything but I'm confused. And let me know, tell uh, you something very honestly. This confusion is completely normal. After UG, you're standing at a crossroads not because your lack of options, but because of you actually have too many options. One path is to lead to industry jobs, another is to go for higher studies like MS and PhD. Some may consider MBA, startups, government exams, or entrepreneurships, and some may even feel pressured to choose a path because others are choosing it. But the most important thing to understand is there is no single correct path after UG. You have to prepare to get into the path. If you want to go to MS or PhD, universities will not ask what was your plan. Universities will ask what have you done to prepare for research. If you want to go to industry, companies will not ask only for your degrees and CGPAs. They will ask what skills do you have and what problems have you solved it. So the real questions after UG is not what should I choose. The real question is how am I preparing myself for the option I want. So there was a project, internships, research exposure become extremely important. They help you to discover what you actually enjoy, what you are good at, and what kind of future you want to build. So instead of being scared by these questions, see the opportunities to explore, experiment, and evolve. So here the next important step is to understand how to structure a research profile. A research profile is not built by overnight. It is a progressive journey where a student evolves from learning basic concepts to finally contributing or original ideas into science. Let me break into different steps. At the beginning, your focuses should be on the building of strong fundamentals like your coursework, basic laboratory exposures, small academic or mini projects. At these projects, no one can expect you to groundbreaking research. It will help you to develop technical skills, basic experimental understanding, and most importantly, research curiosity. And then you move to the second stage of focused. This concentrate on domain of specific projects, summer internships, and literature reviews, where you start reading research papers and identifying research gaps. This is the phase you begin to understand that what problems exist you and what techniques you enjoy with working and which area you want to pursue further. This stage is extremely important for students who are planning for MS or PhD because it shows directions and seriousness. And the final stage is uh, strong and visible stage. At this level, you have to prepare for your thesis level or long-term projects, conference papers, and journal publications. These outputs demonstrates research community, research maturity, problem solving ability, independent thinking, and scholarly communications. So, one of the most common mistakes students make while building a research profile is choosing projects just to complete a requirement. But remember, projects are the backbone of your research profile. So, the important question is what makes a project impactful? An impactful project is always a problem driven. Good research does not start with want to use these techniques. It starts with what is the problem I want to solve. In biomedical engineering, this could be a clinical challenging, a limitation in existing treatment or gap in current technology. Always choose a depth to see the projects. It is far better to work deeply on one well-defined problem than to touch in 10 topics superficially. So your project should reflect methodology and thinking and not just results. Even if your results are not perfect, a well-planned methodology shows that you are understanding experimental designs, controls, and analysis. Another important point is alignment with your future goals. If you aim for MS PhD, choose projects that can grow into a thesis or publication level, which means it will lead to a product level also. If you want to aim for industry, choose projects that build relevant technical skills. Now, You have to go with this pathway, like you have to select a global problem and a specific research gap, and finally you have to propose your solution. A clear problem statement, a strong explanation why this problem matters and what you did differently, it is a novelty, and whether the methodology is appropriate, and whether the results are reported honestly, even if they are negative also. Negative or inconclusive results are not failure. You just has to incorporate in honest results. So when you select a project, don't ask is the topic is trending. Ask instead, does the project help me think like a researcher? So now let me explain research paper writing using a very simple and fun example with pizza. Look at the first pizza on the slide. It is simple, a good base, the right amount of sauce, cheese, vegetables, and meat. Nothing extra, nothing confusing. It doesn't try to impress. It just makes it sense. This is exactly how a good research paper should be. Now look at the second pizza. It has fried chicken, chocolate spread, colorful candies, cheese, olives, and spicy sauces, all on the same basis. Each ingredient is expensive, each ingredient is good on its own, but together it is confusing. So you don't know what you are tasting. This second pizza is what happens when students try to write a research paper by adding everything they know. So more techniques, more leads to better paper, more experiments, more impact, and more keywords will leads to higher acceptance. So, but that is not a true. A research paper is not judged by how many ingredients you add, but by how well they are combined. So the base is your combined with pizza, like the base is your problem statement, and the sauce is your problem matters, that is which means the research gap, and the toppings are your methodology and results, and the final taste is the clarity and logical flow of your paper. So a research paper is not judged by how many ingredients you add. So this is the essential sources and platform tools for different purposes. For literature, before doing any experiment, you must understand what is already known. Platforms like you have to use some platforms like Google Scholar and Scopus help you to read quality research articles, identifying research gaps, and avoiding repeating existing works. Good research always starts with good reading. For learning, if you feel your concepts are weak, that it is not a disadvantage. It is an opportunity. A platform like Coursera, NPTEL allow you to learn advanced topics and global experts, often free or at very low cost. For modeling and simulation, not all research happens in wet labs. Tools like MATLAB, COMSOL, and Python are widely used for computational modeling, data processing, and simulation based on studies, especially valuable in biomedical engineering, which can be used in modeling. For wet lab work, when working in the lab, following standard protocols is critical. So platforms like protocols and help you to design experiments, document setups, and maintain reproducibility, something reviewers can care deeply about it. For data analysis, you can use ImageJ software and GraphPad Prism for meaningful results and figures. For research writing, you can use Overleaf, and for research reference manager, you can use Zotero and Mendeley softwares. For AI softwares, you carefully listen to that AI is a supportive tool, not as a substitute for thinking. For networking, you have to use platforms like ResearchGate and ORCID to connect with each researchers and shows your work and build a professional academic identity. For prototyping, finally, the ideas become impactful when they become tangible. Tools like Arduino and 3D printing allow you to convert concepts into real prototypes, especially useful for biomedical devices and engineering solutions. So here we are comparing that MS after jobs and we are doing MS after researchers. Gain specialized skills, has hands-on trainings and exposure to real-world problems. MS is the duration of 1 to 2 years and coursework plus mini research or project. Research depth is limited but focused. Here it was clearly mentioned that the difference between MS and the research work. And for a research work, duration of is 4 to 6 years and focuses on research intensive minimal coursework, but research depth is very deep. Publication is mandatory and multiple quality papers are recommended. Funding is mostly funded like stipend, like that. Outcome is you become an independent researcher or scientist. A PhD builds leader of knowledge, scientists, professors, and high-level R&D leaders. Only choose PhD if you enjoy asking why more than how, and you are comfortable with uncertainty. You like deep, long-term problem solving, and you want to lead research, not just apply it. So small different, simple in keywords are MS teach me advanced skills so I can apply them or well. Like PhD, let me push the boundary of the knowledge itself. So MS innovation is application oriented and PhD innovation is discovery oriented. So for MS after jobs, the biomedical engineer can apply for biomedical engineer position and my medical device engineer. For biomedical engineer position, this is the role where you apply for engineering principles to solve healthcare problems. You may work on device like design, data analysis, testing, or system integration in hospital and companies. So for medical device engineer, this role focuses on designing, developing, and improving medical devices such as implants, diagnostics, instruments, imaging systems, and wearable health technologies. Strong skills in designing materials, testing, and regulations are highly valued here. In biomaterials and tissue engineering scientists, if you have enjoying lab work, materials, and biology, this role is involves developing scaffolds, hydrogels, implants, and regenerative solutions. This is a highly research-driven industry role, especially in startups and R&D divisions. Like clinical engineer, work closely with hospitals to manage, evaluate, and optimize medical equipment. This role bridges engineering and clinical practice, ensuring patient safety and device performance. Like quality and assurance and quality control engineer, these roles are extremely important in biomedical and medical device industries. You ensure product meet safety, performance, and regulatory standards. These roles are ideal for students who are detailed, oriented, and interested in compliance and validations. Regulatory affairs specialist. This role deals with approvals, documentation, and compliance with regulatory bodies like FDA, CE, etc. And regulatory professionals are critical for taking products from lab to markets. Product manager like medical devices and health tech. If you enjoy both technology and strategy, product management is great option. Here you coordinate between engineers, clinicians, marketing and regulatory teams to guide product development. And at last, entrepreneurship. As startup founder, some biomedical engineers choose to build their own startups, developing medical devices, diagnostics, digital health platforms, or biotech solutions. As MSU gives us a technical foundation needed to innovative and commercialize ideas. So here is some of the areas of future biomedical engineering, which covers the bioelectronics, synthetic biology, organ on a chip, regenerative medicine, smart biomaterials, AI and ML, artificial intelligence and machine learning in medicine, multi-omics, wearable technology, immunoengineering, digital health and security, human mission integration. These are the futures of biomedical engineers. And some common mistakes that many students have to solve it is, instead of always taking a clear research question and identify a research gap. Skipping literature review is the major common mistake that students have been done. Some students jump directly into experiments. This often leads to repeating the existing work. Always read at least 10 to 15 recent papers before starting any projects. And treating biomedical engineering as only biology or only engineering is the another major drawback. Biomedical engineering is interdisciplinary. If you focuses on only one side, your work becomes weak. Balance biology plus engineering and also computation. Chasing trending topics. You are chasing a trending topics attract high competition and shallow projects. Combine your strengths with an emerging area. So poor experimental controls, doing experiments without plan, ignoring negative results. Negative results are often hidden, but this leads to incomplete science. Report failures with clear explanations has to be evolved because negative also a result for the researchers. Weak data analysis, poor analysis leads to misleading conclusions, poor scientific writing. So, because you have to follow the writing based on problem and research gap, methods, result, and the impact. Copy pasting with AI misuse can lead to plagiarism and rejection. Use AI only for clarity, structure, and grammar, not thinking. So publishing in low quality journals, you have to publish your papers in reputed indexed Scopus indexed journals. So ignoring ethics and safety, you have to properly follow the ethical and biosafety guidelines. So working in isolation, research grows faster with guidance and collaboration. So you have to make connection with researchers and professors to make research easy. So these are the drawbacks of common mistakes which made by the students. So here we go for an approaching in how to approach an internship and for researcher. For internship, you have to get labs. You have to choose labs that actually work in your area of interest. Quality matters more than quantity. Read recent papers. Read at least 2 to 3 papers from the lab. Prepare an academic CV for to keep it concise, education, skills, projects, and tools, and no unnecessary information should be included. Write a targeted email. Never send generic emails. Mention the professor's work and how you are interested in that work. Email professionally. Be polite, clear, and brief. So you have to follow up the process for 7 to 10 days after you have sent to the mail to a professor or some management, and you have to discuss it with the uh, discuss and give the interview to that internship process. And for research, even if it is small, define what question interests you and look for alignment in problem, methods, and vision. Understand the lab's direction and ongoing questions. Highlight how your skills can help the lab, not just what you want. Clearly explain how you can contribute to ongoing research, and persistence with respect is appreciated. Once you have contributed to the lab, take the ownership of your work. Sorry for the inconvenience. Okay. This was my work, which was created by 3D printed scaffold, 3D bioprinting using living cells. Many of you are already familiar with 3D printing, and now the emerging technique is 3D bioprinting, which is used like a biopolymer and biomaterials like soft and gel-like material, which is combined with the living cells. And these cells may have to stabilize using light or chemicals to give the structural stability and without the harm to the cells or living tissues. So by using these techniques, you can mainly used for disease study, drug testing, tissue engineering purpose, and for mainly for reducing the animal harmful things. So now we are going to conclude this session. Biomedical engineering is a field driven by curiosity, interdisciplinary thinking, and continuous learning. While challenges exist, rapid technology advances and collaborative approaches are steadily pushing the field forward. The goal of the seminar. Okay. Okay. I think this slide also I didn't focus it. This is the list of top colleges and universities in India and abroad, the most major colleges and universities. In India, we can focus IITs and VIT, NIT, Bharat Institute of Higher Education and Research, and Karunya Institute of Technology and Science in Coimbatore. And and in abroad, John Hopkins University, University of California, and MIT, ETH, and National University of Singapore is a major role for biomedical engineers for higher studies like MS and PhD. Uh, this is the major competitive exams which will focuses in India and abroad as well as abroad. In India, we can focuses in GATE, CSIR, NET exam, UGC, JRF, ICMR for JRF, and DBT, JAM exams, and institute reviewers. Is common in India. And for abroad, most IELTS exams is mandatory for abroad, and these are the exams you have to focuses. And this is the advanced technique in biomedical engineering, like 3D bioprinting. This is my work, and based on this work, instead of 3D printing, we have focused with the biological material into the engineering technology. We incorporated this both techniques, and we have printed a living cells in the scaffold like thing. So a biomaterial which is soft and mixed gels which will be layer by layer, which will be as additive manufacturing like layer by layer. After printing the structures, you have to stable using light or chemicals for cross-linking purpose to stabilize the structure without damage or harmful to the cells. So this method, this field can be used in disease studies, drug testing, and tissue engineering research to reduce the harmful to the animals and to sacrifice the animals and to reduce sacrifice to animals. So, in conclusion, biomedical engineering is a field-driven curiosity, interdisciplinary thinking, and continuous learning. While challenges exist, rapid technology advances and collaborative approaches are steadily pushing the field forward. The goal of the seminar was not just to share information, but to ignite curiosity, strengthen your understanding, and motivate you to explore biomedical engineering further through projects, research, higher studies, already have industrial applications. I hope today's sessions has helped you to clear pathways and new possibilities for your academic and professional future. Thank you for your time. And if you have any doubts and questions, kindly clarify.
Once again, a warm welcome to all the participants. We have now come to question and answer session, which is one of the most interactive and valuable part of today's program. This session is an opportunity for you to clarify your doubts, share your thoughts, and gain deeper insights from our esteemed speaker. Participants are kindly requested to fill out the feedback form. Once you have submitted the form, you will receive Biomedical Engineering Reference Book. Author names are R.S. Kanpur and Cromwell. Thank you. I believe there are no more questions from the participant. Shall I conclude the session with the vote of thanks? Please anyone reply. A very good evening to everyone. As we come to the conclusion of today's seminar, it is my honor to deliver the vote of thanks on behalf of the BioCareer Circle community. First and foremost, I would like to express our sincere gratitude Dr. Lakshmi Priya for delivering such a valuable and insightful session. Your guidance on building a strong research profile, choosing project, publishing paper, and securing internship has been extremely informative and motivating for all participants. I also thank all attendees for taking the time to join us and for your active participation throughout the session. A special word of appreciation to the organizing members and volunteers of the BioCareer Circle community for their efforts in coordinating today's program smoothly. Thank you once again to everyone for making this event success. Wishing you all the very best in your academic and research. Thank you.
Thank you.
Thank you, ma'am.